Hello learners, this is Education Online program. With you is teacher Rose Hezekiah, and I'm here to present for you a lesson in chemistry for senior 1 and 2. Our lesson for today is about the electrochemical series. Electrochemical series. The electrochemical series is simply talking about the arrangement of elements in order of their reactivity. Electrochemical series is the arrangement of elements in order of their reactivity. How reactives are metals, how reactive an element is compared to the other. So we have that in the reactivity series, the most reactive elements are placed at the top, then the least reactive are at the bottom. So we know that all elements are grouped into metals and non-metals. So we have the most metals. Let us look at the reactivity series of metals first. We have the metals. The metals usually react by losing of the outermost electrons. So they lose these outermost electrons, they form positive ions, therefore they are called electropositive. They are called electropositive. Electropositive elements. Metals react by losing their outermost or we say they react by losing electrons in their outermost energy level. They react by losing electrons in their outermost energy level. Therefore, they are called electropositive. They are electropositive. Metals are electropositive. So they become electropositive when they lose their outermost the electrons in their outermost energy level. So when metallic elements lose electrons in their outermost energy level, they become electropositive. Therefore, in comparison, metallic elements that readily lose electrons in the outermost shell, metallic elements that readily lose electrons in their outermost shell are the most reactive elements. So the most electropositive elements are the elements that readily lose electrons in their outermost energy level, and they are reactive. And those ones that least readily that least readily lose electrons in their outermost energy level are least electropositive. They are least electropositive. That is, they are least reactive. They are least reactive. So let us look at the electrochemical series of metals. We have the most reactive metal is potassium. Followed by sodium. We have calcium, magnesium, aluminum. We have carbon, zinc, tin, lead, copper, silver, mercury, silver, and then gold. This is calcium. We have magnesium. We have aluminum. We have carbon. We have zinc. We have tin. We have lead. We have copper, mercury, silver, and then gold. So the reactivity decrease downwards. So we have, this is the most electropositive and the most reactive metal is potassium. Then down here we have the least electropositive. The least electropositive is the least reactive metal, which is gold. So reactivity decreases as you move from top to bottom in the electrochemical series. So we have, although hydrogen and carbon are not, oh sorry, I did not place hydrogen. So we have lead, zinc, then there is iron, we have tin, hydrogen, then copper, mercury, silver, and then gold. So this is iron, this is tin, this is hydrogen, this is copper, mercury, silver, and then we have gold. So as I said, the most electropositive element is at the top, that is potassium. Potassium is the most electropositive and the most reactive, followed by sodium, calcium, magnesium, aluminum. So reactivity of metals decrease as you move across the reactivity series from top to bottom. So we have the least electropositive is the least reactive, which is gold. Although we have hydrogen and carbon, they are not metals. They are included in the series to show the position they would occupy if they were metals. So they are placed here to show the position they would occupy if they are metals. So if suppose that hydrogen carbon is supposed to be a metal, then this will be the position of carbon and this will be the position of hydrogen. But both hydrogen and carbon, they are not metals. Then let us look at the reactivity series of non-metals. So non-metals react by gaining. As I said, metals react by losing their outermost energy level electrons. But non-metals react by gaining electrons in their outermost energy level. So when they gain electrons in their outermost energy level, they become electronegative. They become electronegative. So before we go to non-metals, we have let us consider the reaction. We consider the reaction of oxygen with metals. So oxygen reacts with metals vigorously. And then with decreasing vigorousness. That is from top to bottom. Also, the reactivity of metals with oxygen decrease. Like we have when we heat metals with oxygen, they form metal oxides. But when you come down the series, we have copper and then mercury. Down in the series, they only form a layer of oxide. But for the rest of the reactive metals, they form metal oxides. But in case of copper and mercury, when they are heated in presence of oxygen, they form a layer. They form a layer of oxygen. They form a layer of oxygen. But when you proceed down, we have gold. That is Au. When you heat gold in presence of oxygen, it doesn't react. It doesn't react with oxygen. So any metal higher up in the series can displace any metal below. So in reactions, you have any metal higher up in the series. In reactions, you have potassium can displace sodium, calcium, magnesium, aluminum. That is, potassium can displace all these metals in chemical reactions because it is higher up in the series and it is the most reactive. Sodium can displace calcium, magnesium, and the rest of the metals. But the metals below cannot replace the metals up in their reactions. So, for example, we have a reaction of zinc metal that is solid reacts with copper sulfate that is aqueous. This will give us zinc sulfate aqueous in aqueous form plus copper metal. So if you see here, zinc displaces copper from copper sulfate. Why? Because in the series, zinc is higher than copper. That is simply zinc is more reactive than copper. So any metal that is more reactive than the other displaces the least reactive in reactions. We have iron metal that is solid plus sulfuric acid plus sulfuric acid, aqueous. This will give us iron sulfate in aqueous form plus hydrogen gas So when you look at iron is above hydrogen in the series. That's why iron displaces hydrogen from sulfuric acid to give us iron sulfate plus hydrogen gas. Then we have magnesium solid plus hydrochloric acid, 2 moles of hydrochloric acid in aqueous form. This will give us magnesium chloride in aqueous form plus hydrogen gas. So also magnesium is high up above hydrogen in the series. That's why magnesium can displace hydrogen from hydrochloric acid. So copper does not react with dilute acids because it cannot displace hydrogen from its acids as it is. So when copper reacts with acids, it cannot react because copper is below hydrogen in the reactivity series. So it cannot displace hydrogen from its compounds. Then also we have oxides of metals below carbon in the reactivity series are reduced by carbon to metals. So we have like copper 2 oxide, that is solid, plus carbon solid. Then this will be reduced to copper metal plus carbon dioxide gas. We have lead oxide plus carbon metal. This will be reduced to give us lead plus carbon dioxide gas. So we have oxides of metals below carbon. That is oxide of copper and oxide of lead and oxide of lead. Oxides of carbon and oxides of lead. So in the series we have lead. In the series we have tin, we have lead, we have hydrogen, we have copper, we have mercury, silver, then we have gold. So we said that, as I mentioned, oxides of metals below carbon cannot, in the series, are reduced by carbon to metals. So we have copper and lead. We have, this is copper and this is lead, and both of them are below carbon in the series. Both of them are below carbon in the series. So their oxides can be reduced by carbon into metals. So here we have copper 2 oxide plus carbon is reduced to copper metal plus carbon dioxide gas. We have lead oxide plus carbon. Lead oxide is reduced to lead metal plus carbon dioxide gas. Then let us look at the electrochemical series of non-metals. The electrochemical series of non-metals. So as I said, non-metals react by gaining electrons in their outermost energy level. So those non-metals that readily accept electrons are the most reactive. And those non-metals that least accept, or they are not ready, they don't accept electrons easily, they are least reactive. And when non-metals accept or gain electrons, they become electronegative. So the ones that accept electrons easily are the most electronegative and the most reactive. And those ones that do not accept or gain electrons easily are the least electronegative and least reactive. So let us look at the electrochemical series of non-metals. So we have the most reactive non-metal is fluorine, followed by chlorine, bromine, iodine, we have oxygen, sulfur, phosphorus, then nitrogen, and then the least reactive non-metal is carbon. So we have this one, reactivity decrease. So we have, this is the most electronegative, and then this is the least electronegative. This is the least electronegative. So the most reactive nonmetal is fluorine, followed by chlorine, bromine, iodine, oxygen, sulfur, phosphorus, nitrogen, and carbon. So those elements which readily accept electrons, they are most electronegative and they are the most reactive. And those that do not easily accept electrons, they are least electronegative and they are least reactive. So we have elements which accept, we have elements which readily accept electrons are most electronegative or most reactive. And then elements that least readily accept electrons are least electronegative. They are least electronegative or least reactive. They are least electronegative or least reactive. So in the series, we have fluorine is the most electronegative or most reactive. And the least electronegative or least reactive is carbon. So, dear learners, we have come to the end of our lesson for today. See you in the next lesson. Bye-bye.